All right. So this one, we're going to find our starting point. I like a start point and sometimes a stop point. So that's the first thing I do. I find the start and the stop. And then the second thing I do is I decide which kind of function it is. What kind of function am I dealing with? Because that tells me what to do. If it's just a line, then all I have to do is slope. If it's a parabola, then I have to find the vertex and square my moves until I get to this start or this stop. Okay? So let's do it. Number one, we find our start point by plugging in the x value. So if I plug in the 0, I get out -1. Now this start point on this one's going to be an open circle. It's an open circle because there's no equal to. And so I'm going to put an open circle at 0, -1. All right? I'm going to make mine a little more obvious by whiting out the middle. Okay, now I look at this. It is a line. 3x minus 1. That's slope-intercept form. So when I'm graphing a line, really all I need is the slope if I already have a point to start from. And I have a point. And then I decide which way do I get to go. I get to go the way where x values are less than 0. Is that right or left? Left. So I get to go left from this point, and the slope is +3, which normally I would like to go up 3 and right 1. But I don't get to go right. So what slope is equivalent to up 3 and right 1? Down 3 and left 1. There's the first piece.
That's where I go wrong. I get the points down and then
Okay, second piece. The second piece has a start and a stop. So if I plug in 0, I get out 0. And if I plug in 4, I get out a crazy large number. 4 squared is 16 times 2 is 32. That was a good choice. Not really. All right, so at the 0, 0, it's a closed.
Oh wait, we changed that one.
We changed this one? Oh, good. What did we change it to? Square root?
Yes.
Oh, so smart of us. Okay, let's change it then, because we changed that one in class. Somebody asked about that before we left. Good. So that's going to change this. Yay. So we changed this to the square root of x. Much better. So now if I plug in the 4, the square root of 4 is 2, and 2 times 2 is 4. Yay. All right, so a close at 0, 0, and an open at 4, 4. So closed at 0, 0, open at 1, 2, 3, 4, 1, 2, 3, 4. Now we have to go, what kind of function is this? This is a square root. So with a square root, I would start at the transition point, which is 0, 0, and then I'd say the square root of 1 is 1, but there's a 2 in front, so I double it. The square root of 4 is 2, but there's a 2 in front, so I double it. I got to my stop point, that's all I do. I just make sure I go from my start to my stop. Does that make sense? All right, last piece. So the first thing I do is I plug in my x to find my start point. So I plug in 4, and I get out -3. Now this has the equal to, so this is going to be a closed. At 1, 2, 3, 4, -3, closed dot. There's my start point for this one. So now I have to go, all right, what kind of function is it? This is a line. And to graph a line, all I need is slope. So my slope is -1. See, that coefficient of your x is understood -1. And this one is for x values that are bigger than -4. Which way is that? Which way is bigger? Not -4, bigger than +4. That is right. So I go down 1, right 1. Down 1, right 1. And it goes forever. Be good if you guys could make it actually go through the dots. There we go. All right. And that is piecewise functions. Every time. Those are the steps you do. That's how your brain has to think about it. Yes, sir.
Never mind.
Okay. So let's go to the next one. The first one is a cubic. And if I plug in the 0, I get out -1. It's going to be a closed. 0, -1, closed. Now there's my start. I don't have a stop. So now I just have to figure out what can I do. This one only gets to go left, and it's a cubic. So I'm evaluating what kind of function is this? Cubic. Where does this cubic start? Well, the starting point is actually the translation point. And a cubic, I cube stuff. So 1 cubed is 1, but I don't get to go right. I only get to go left. So -1 cubed is -1. -2 cubed is off my graph, -8. So it doesn't even look much like a cubic because we only have this little part of it. We don't even get the inflection. We only get half of it because we don't get to go right. This says, nope, got to stop right here. All right, middle piece. Middle piece has a start at 0. Plug in 0, get out -3, open circle. 0, -3, open circle. This one also has a stop. If I plug in 3, 6 minus 3 is 3. So it has a closed stop at 3, 3. Now, we look at it. What kind of function is 2x minus 3? That's a line. So all I do is slope. Up 2 over 1. Up 2 over 1. Up 2. Oh, hit my stop. So I stop. Connect the dots.
You have.
Last piece. All right, so last piece only has a start. We plug in 3, we get out 3. It's an open circle. Now this is a unique thing that happens with piecewise. One function just rides right on top of the other one. Now, if it's pencil, you can't even tell I just did that open circle. And that's fine. You shouldn't. That point gets filled in with the middle one. So, now this one goes right. And I have to figure out what is it. What is this function? Squared. It's a parabola. And the vertex would be 3, 3. Oh, that was my starting point. But this says I only get to go right. So I don't get the left side of the parabola, only the right. 1 squared is 1. 2 squared is 4. So all I get is the right side of this parabola. Make sense? Okay. All right, I'm just going to open up the answer key for the rest of it. Actually, no, I'm not. I'm going to show you the rest of it. Now, that worksheet that I gave you yesterday, I'm going to check it tomorrow. Because I'm pretty sure if I checked it right now, a lot of you would get a 0. Or a 1, with me being generous. Some of you would get a full grade. I understand that. But I'm going to give you an extra day on that one. Okay? So you can ask me some more questions when I give you a chance today in class. The 2 problems I just did, does that help it make more sense? Okay. I'm going to go ahead. I'm going to work these 3 then. And then I'm going to count on you to go back and redo that worksheet from yesterday. If you didn't get it done, now you have an extra day to have that opportunity, okay? I will be here in the morning. Tomorrow's Wednesday, right? Yep, I will be in here in the morning. So if you're still struggling, I'm available at 8 a.m. for help. Okay? All right. Let's go ahead. We'll do these 3. I'm going to snip this real quick. I'll just actually snip it. it go? There we go. Alright, so there's our function. I'm going to go ahead and put it on here so I have, you know what, that's too hard to read. I'll just put a regular graph. Nope. Okay, so we have to find our start point. The start point for this one would be 4, 0. Plug in 4, get out 0. 4, 0, closed. What is the top function? A line. Which way does this line get to go, right or left?
Right.
Left.
What?
Left. The x values that are less than 4. Okay, now, here's a trick, which I hate tricks. I like understanding, because if you have understanding, you don't ever need tricks. But if the x comes first, this is the only time this trick works. I'm telling you because it's trick or treat day. Whatever direction this is pointing is the direction you get to go. If the x comes first. If the x does not come first, that rule doesn't work. So this one gets to go left because it's pointing left. Actually, because it's less than. That's why it gets to go left.
Wait, I think you said right. It gets to go right.
This one goes left. It's x values that are less than or equal to 4. So x values that are less than or equal to 4 are this way. Okay? So the slope is -2, which normally means down to right 1, down to right 1, but we don't get to go right. So we have to do the opposite of that. Up to left 1, up to left 1. And then we will graph in that ray because it keeps going. Yeah. All right, next one. This one's going to start at 4, 2, but it's going to be an open circle. So 4, 2, open. This one gets to go right. It's x values that are greater than 4. That is right. So the slope is 1/2, up 1 over 2, up 1 over 2. Graph your ray. And that is it. That's all there is to it. Okay, next one. All right. So the starting point for the first one. Plug in -2, get out -1. Open or closed? Open. -2, -1, open. It is what kind of function? A line. And the slope is -2, so we go up 2 and left 1, up 2 and left 1, up 2 and left 1, because we cannot go right. And then we sketch in our ray. All right, the next one starts at -2, plug it in. -2 squared, 4. 4 minus 3, 1. Solid. Okay, so what it does is it fills in. When you're doing this with pencil, you won't even be able to tell. It'll look like they're sharing a point.
Stop.
Oh, it is up. I just lied. It's +1. They're not sharing a point at all. All right, so now, this is where we have to do our investigation. What kind of function is this? Parabola. Where would the vertex of this parabola be? 0, -3. 0, -3. So with a parabola, we go right 1 up 1, left 1 up 1. Right 2 up 4, left 2 up 4. Oh, I hit the point. I don't go any further. So now I can draw it in. Whee! Okay? were about to do the last one you had to graph. Finally. Okay. Huh? Okay, so let's snip this one, and then we'll move on. Snip. Ooh. Okay, so I need a graph. All right, the first one's going to start at 0, 0, and it's going to be solid. 0, 0, solid. Start point. This one only gets to go right. That's not right. That's left. That's left all day long. Less than left. Okay? And then what is it? It is a parabola. And the vertex would be at 0, 0. Well, that's where I started, so that makes it a little easier. But I only get to go left. So 1 squared is 1, but there's a half. 2 squared is 4, but there's a half. 3 squared is 9, but there's a half. So it's this side of that compressed parabola. That's the worst looking thing I've ever seen. All right. Now, the next one. We're going to plug in 0, and we get out -4. We have a start that's open. Then we're going to plug in 3, and we get out 4. We have a stop that's closed. So we have one at 0, -4. 1, 2, 3, 4. Okay, and we're open there. And then we have a closed at 3, 1, 2, 3, 4. All right, so this start is actually where that translation point would be. And you guys studied exponentials for about 4 weeks in 9th grade. Anybody remember? Yes! I'll take it. All right, so our moves for exponentials come from this. So if I moved right 1, what's 2 to the first? 2. If I moved right 2, what's 2 squared? 4. If I moved right 3, I have to stop right here. I didn't put that point in the right place. Here we go. That's an exponential. And the last one. When I plug in 3, 6 minus 2 is 4. The starting point on this one is an open circle at 3, 4. And my slope is positive 2, up 2 over 1, up 2 over 1. All right, and then the last two we're just evaluating. Whoa. So we will snip these and paste them into that same page, and then we'll be done. All right, so on the first one, G of -2. Does that get plugged into the top, the middle, or the bottom function? Top, middle, bottom. Middle. -2 is in between -3 and 1. So 4 minus 3 is 1. All right, G of 2. Does that get plugged into the top, middle, or bottom? Bottom. Oh, there's no place to plug it in. So every Y value is 5. 6. Top, middle, bottom. Bottom.
Wait, so multiple ones can go in the same one?
Oh, yeah.
Oh.
Yeah. All right. F of -2. Which interval does that fit into? Which function? Will it go into the top, the middle, or the bottom? Top. So 12 plus 18 is 30. F of 2. Top, middle, bottom.
12 minus 18.
Okay, it's 12 minus 9 times -2.
Oh, -2, right?
Yeah?
I also got the wrong one, sorry.
Okay. All right, F of 2. Top, middle, bottom. that's good enough. 4 to the 6th. It's a really big number. All right. Okay, so you get an extra day on yesterday's worksheet. Extra day. Okay. All right, today. Today's actually may help yesterday's make more sense. Today I'm giving you the graph and we're coming up with the equation. Okay, I can equal to it actually. I have it printed, but then I read an email that some of the problems are duplicates. So I was actually going to speak about that today. Can you speak about that this afternoon? Okay. All right.
Are we still recording?
Yep, we're recording.
Are you saying that so we don't talk?
No, I'm saying that because we're recording. All right, so today we're going to be writing piecewise functions. So we have to think about same questions. Is there starts? Is there starts and stops? What the functions are, and how many pieces we have. So the first one has how many pieces? 2. So on the first one, we're going to end up with 2 things. All right, both of these pieces happen to be lines. This is a line, this is a line. Lines are very easy. Lines fit into y equals mx plus b. Now the first one is actually a horizontal line. So it's just y equals, what is the y value of that horizontal line? 2. All right, so we come down here to the piecewise function. So this will be my line for my first one. I've already got the f of x right there, so I just need 2. Okay? Now, we have to put the restriction. This one has a start and a stop. This should be open. It doesn't look very open. Does it look open on yours?
Yes.
Okay. All right. So we have a start and a stop. So there's 2 ways we could write it. The x value where it starts is -3. It is closed. To the x value where it stops is 0. Or we could write it as an interval.
Are we gonna have to write it as an interval for?
Nope. Okay, the second one is still a line. So this line is not horizontal. It is a diagonal line. So if we came up with the equation for this line, we need the slope up 1 over 2, up 1 over 2, up 1 over 2. So it's 1/2. And we also need the y-intercept, which we can clearly see. The y-intercept on this problem is -2. So it's 1/2 x minus 2. 1/2 x minus 2. There's my equation. Now, it doesn't go forever in both directions, so we have to restrict this domain also. Well, this one doesn't have a start and a stop. It just has a start. So this is starting at an x value of what? 0. Now, which way is it going? Right or left? Greater than or less than? It's going right. So it's greater than. Now, this point right here is closed. So do I get the equal to? Yes. A closed point equal to. Open, no equal to. So if we wrote this as an interval, it would look like that. All right. The second one kind of looks like an absolute value, but it's not. Because both sides aren't quite doing the same thing. They do kind of share a point. But this one has a slope of -1, and this one has a slope of +2. So it can't be an absolute value because that number out in front has to be the same. It would be +2 and -2, or +1 and -1. I can't have two different things. So I cannot actually write this as an absolute value, but I can write it as a piecewise. So let's do the left piece. The left piece. So we're going to separate this into the left side and the right side. So we have a ray that exists here on the left side. It's just part of a line. So for a line, we need a y equals mx plus b. Up 2 over 1, up 2 over 1. The slope is 2. Now we need the y-intercept. It actually doesn't intersect the y-axis. But if we kept going, up 2 over 1, up 2 over 1, do you see it would intercept the y-axis at 3? So, plus 3. So my equation is 2x plus 3. F of x equals 2x plus 3. Now I do have to restrict it because it's not the entire line, it's just a ray. Now this has this starting point right here, and it goes left forever. So it's x values that are less than or equal to, what is the x value right here? -1. Or we could say from -infinity to -1, inclusive. Now my second ray is another line. Down 1 over 1, down 1 over 1, down 1 over 1. That slope is -1. And the y-intercept is 0. We don't need a plus 0. So my equation is just y equals -x. Now, because they share this point, and I chose to include it with the top one, I cannot include it with the bottom. And I get to pick. Like if you wrote not equal to here, but equal to there, you're right. One of them gets the equal to, the other one doesn't. And you get to pick. So this goes from -1 to +infinity. Okay, the third problem. The third problem I would like to be a you try. Now the third problem will have 3 equations. But let's see what you can do with this. And if you need some help, you can let me know. Okay, so we have 3 little lines. Okay, the first one is a horizontal line. So it's just y equals 1. Okay, this one starts at -3 and it goes forever left. It's closed, so it has to be equal to. So that's what it would be as an inequality. This is what it would be as an interval, if you like intervals better. The second one is another line. The slope of this line is up 2 over 3. The y-intercept is clear. It crosses the y-axis right there. Now this one has a start and a stop. The x value where it starts is -3. It is an open circle. The x value where it stops is +3. But it is a closed circle, so I get the equal to here. So that's what that is as an inequality. As an interval, it would look like this. From -3 to 3. All right, the last one, another line. The slope is down 2 over 3, so -2/3. I cannot see the y-intercept, but if I went back and did another slope, do you see the y-intercept would be +2. So you got to give me the y-intercept every time. Now this is for x values that are greater than 3. Not equal to, because that one's open. So if you did it as an interval, it would be from 3 to infinity. All right, this next one I'm going to break up into parts. There's one. Here's the next one. Here's the next one. So this one is 3 different functions. What is the first function? It's a parabola. 1 squared is 1. 2 squared is 4. It's a parabola. All right, so this parabola opens down. So since it opens down, what's going to come in front? A negative. Now with a parabola, it's always squared. And this is how you find the vertex. This is the vertex. The point 2, negative 2, 1 is the vertex of that parabola. So just like with all our other transformations, the opposite goes in here with the x, and what's added to the end is the y. So just like with every other function in transformational form, to find that translation point, which for the parabola is the vertex, opposite, same. So negative 2, 1. Now, we only get to do the left side of this parabola. So it's x values that are less than or equal to, what is this x value right here? Negative 2. Or you could write it as the interval from negative infinity to negative 2. Now, I'm choosing to include that point with the parabola. See, because I chose to include that point with the parabola, I will not include it with this little line segment. Now, this is the horizontal line. The y value on that horizontal line is 1. Now, this goes from an x value of negative 2, but I don't get to include it, to an x value of positive 1. And the last one, what is this function?
Square root.
It's a square root. It's a square root. Okay, so the vertex is 1, 1. The translation point, right here. And I'm choosing to include here, so it's x values that are greater than or equal to 1. So that would be from 1 to infinity. Okay, so the back side's your homework. I know some of you have already started it. On the back, I see a whole bunch of lines. Lines are the easiest. I see part of a parabola. I see an absolute value if you choose to write it as an absolute value. I see a square root. So, really?
It's not right.
All right. So have fun.